because it was based on this ISC standard, and here you can see its spectrum. And we generated it basing on 1 minute of pink noise, which we then equalized to get the correct spectrum. And we then corrected for the RMS value using Adobe Audition. And we corrected for a minor distortion, and we measured this sound to be compliant with the ISC standard. Anyway, there was this Alastair Hardy guy who found that our crest factor was not standard compliant. We believe this was caused by the fact that the standard was based on analog measurements, which systematically underestimated the result. So we tried to emulate this employing, once again, Adobe Audition. We specified a window width of 35 milliseconds, and with the statistical analysis tools, this should give us the correct pseudo-peak value, adding 3 dB to the result. And this gave us a standard ratio according to the EN standard. Furthermore, this Mr. Hardy sent our test file to the National Physical Laboratory of London and to another lab, and these are the results. It will seem that the signal is standard compliant, although there is this 0.09 decibel error, which we think is alright. Then we used a music test signal, which is a signal which we generated using this spectrum, which we obtained averaging all the music present on the red digital audio players. So we collected all the music and we played it back with a VLC media player, digitally rerouting the audio output to the spectral RTA software, and we measured with 1/3 of octave spectrum. This is a screenshot of the software. This is the time history of the SPL. As you can see, it is very varied depending both on musical genre and the musical compression employed. Then we generated the signal using the same system. So we first made the pink noise, and then we corrected the spectrum and so on. Here we have a brief comparison between the two signals. As you can see, there is an increased bass content in music, and the RMS value is minus 9.2 dB from the music test signal due to music compression. Here we can hear the two test signals. This is the ISC one, and this is the music one. There is almost no difference from an auditory point of view. In order to use the test signals with various devices, including Apple iPods, but also Creative Sense, Resumes, and so on, we had to use different file formats, but we didn't discriminate the results, the SPL value didn't change between the various formats or bit rates. In order to perform our measurements, we used a dummy head, which was specifically manufactured for testing internal hearing aids, and which is a standard compliant. We calibrated it using a Brollekeer reference sound source, and we used the calibration signal also for the measuring software using this included module. Then we also corrected for the free field frequency response of the ambassador dummy head using measurements made available by Ritter Automotive. And this is the given spectrum for the ambassador dummy head. And we then use the microphone compensation custom weighting module of spectral RTA for applying this correction. Then we measured a linearly averaged spectrum in 1/3 of octave bands, averaging the signal of both channels, and we computed an unweighted spectrum and an A-weighted wideband value. We had a 1 minute long test signals in order to start the signal before the actual measurement started, so that the device could stabilize before measuring, and that we only measured during the playback of the signal with no silence in between. And this is again a screenshot of spectral RTA operating. There is a bit of formatting error here. Well, anyway, we mounted and unmounted the earbuds every time as prescribed by the EN standard, because there is a big difference between the position of the earbud in the ear duct and the measured SPL. So in order to average it, we mounted and unmounted it 5 times. For getting a better correlation between the two test signals, we used a single position for each signals. That is, we measured for each position with both signals before changing the position. An important thing is that we didn't change the volume settings of the players. We just put the test signal on it and we measured the SPL with the last volume settings in order to get a statistically relevant depiction of at what level the teenagers actually listen to the MP3 players. Well, this is a picture of an earbud in the pin, and this is the whole measuring system. So we have an MP3 players whose headphones are inserted in the pin of the dummy head, who it is connected through an audio cable to a laptop PC which is measuring it. So here we have the results. We got an exposure sound pressure level for each signal for each device. So here we can see that most SPLs are over 80 dB for both the ISC test signal and the music test signals. And there was actually almost no difference between the two results, while there was a lot of difference between devices. Also, when there was the same manufacturer and the same model, it was all about the volume settings. And here we can see graphically the dispersion of the result, which is quite big. As you can see, this is the highest one, it is more than 100 dB, and the lower one was about 60 dB, so there is more than 40 decibels of dispersion. We had some problems with frequency response, as we found peak at 3 kHz due to ear duct resonance, and a dip at 5 kHz due to free field correction of the dummy head. We can see that it is caused by the correction because there is a peak corresponding to the dip in the results in the ambassador dummy head frequency response.